Hello everybody. In this video we are covering lesson 6 in our vertebrate unit on mammals. So without delay, let's go ahead and get started. We are talking all about class Mammalia today. So as a review, we are in Kingdom Animalia, phylum Chordata, subphylum Vertebrata, class Mammalia. So this is the highest class of animals, and there are 6 basic characteristics that are in existence of all mammals. Please make sure you know all 6 incredibly well. So make sure you study these 6 characteristics. So there are presence of specialized glands that produce milk called mammary glands. And I've got a picture of those in a marsupial in an upcoming slide. So I'll point those out. Next, we have hair or fur at some point in a mammal's development. Even in the dolphin, which I'll show you here, dolphin and whales, they actually do have hair follicles. Okay, so when a baby dolphin comes out, and this is an Atlantic bottlenose dolphin, you can see these spots here and here and here. These represent their hair follicles, and you'll also usually see them right under here, under this underside of the rostrum. This nose that you would call it is actually called a rostrum. Okay, and these hair follicles are where the remnant hair, or vestigial hair of a dolphin and their ancestors comes out. All right, so all mammals at some point in time have hair or fur. There are 3 middle ear bones in all mammals, affectionately known as the stirrup, the anvil, and the hammer. The stirrup is actually the stapes bone, and that's right here. The anvil is the incus, and that's here. And then we have the hammer, or the malleus. Okay, so as long as you know that the mammals have 3 inner ear bones, then we are all set. Okay, at this level, I'm not going to ask you to memorize malleus, incus, and stapes. But if you can remember stirrup, anvil, and hammer, that'd be a good thing. All mammals have 1 bone in their lower jaw. So their lower jaw is fixed. It has 1 bone in it. Okay, unlike a snake jaw, which has 2 separate bones in their lower jaws. All right, another thing that all mammals have is an aortic arch, which I'll show you when we look at the heart. Okay, so the aortic arch. And in a mammal, it curves to the left. And remember, if we're looking at a heart, that's a terrible drawing of a heart, I know, but we've broken it up into our 4 chambers. This side is the left side, and this is the right side. So the aortic arch, this thing, okay, this curves this way. And you'll see when the blood flow, it makes a little bit more sense. So stay tuned on this one. We'll talk more about it. And finally, all mammals have the presence of a diaphragm. And a diaphragm is a muscle underneath the rib cage that assists us in our breathing. So during inhalation, when we're bringing air in, this diaphragm stretches out. So it actually goes this direction. When we exhale, that diaphragm goes upwards into the rib cage, and it pushes that air, makes the lungs smaller. Okay? So inhalation, the muscle expands. Exhalation, the muscle contracts. And that is the diaphragm. We all have internal fertilization. So internal fertilization in mammals. Okay? And we all have internal gestation, and that is called viviparous. So vivi is live or life. Okay? Or live birth. Live birth. Most mammals give birth to live young. These mammals are called placentals. All right? The vast majority of mammals are placentals. Humans are placentals. We are developed in a female's placenta and are born throughout the uterine canal. All right? But there are 2 other kinds of mammals, and you will need to know these kinds of mammals and how they reproduce. So the 3 kinds of mammals are placentals. They give birth to live young. Next, we have monotremes, which are mammals that lay eggs. They are oviparous. Remember that word from reptiles, the oviparous. Okay, they lay eggs. That's what ovi means. Ovi is eggs. Parous is birth, if you will. So lay eggs. All right. Examples of this is the duckbill platypus and the echidna. The echidna is this little dude right here, and the platypus is way over here chilling in wherever he goes. All right, so platypus and echidna are 2 representatives of mammals that are monotremes. And again, monotremes lay eggs. Know that. No placentals give birth to live young. No monotremes lay eggs. And finally, the 3rd kind of mammal is called a marsupial. and they are born as embryos. This is actually an embryo of a marsupial, and this is that mammary gland that are present in all mammals. Now, mammary glands take many shapes and sizes. This is what a kangaroo's mammary gland looks like. So an example animal of your marsupial is a kangaroo. That's the most famous or most well-known version of it. They are pouched mammals. The kangaroo is born as an embryo. The embryo crawls up into a pouch where the mammary glands are, and they develop the rest of the way in that pouch. Okay, so 3 kinds of mammals: placentals, monotremes, marsupials. Know the differences, know how each kind of mammal gives birth. Now we're going to get into dentition. Dentition is nothing more than teeth. Okay, so mammal dentition, the structure and type of teeth that are in the jaw. There are 4 kinds. You need to know all 4 very well. All right, we have the incisors. The incisors are typically, if we're looking at this human jaw here, we see that we have 4 incisors. Now this will vary based off of the species that you're talking about, but for humans we typically will have 4 incisors on the top and the bottom jaw, followed by canines, and this is on the side, so that's these guys here and these guys here. For you vampire lovers, the canines are the teeth that get extended, okay, to pierce the skin of a waiting victim, if you will. So incisors are in the front of the mouth. Backtracking for a second, incisors, front of mouth, and they cut, grasp, or pick. All right, so this is grasping. A classic meal for meat eaters that are humans would be baby back ribs. Okay, typically you grasp the rib meat with your front teeth or incisors. Then you have canines. That's on the side of the mouth, and they tear and shred. Canines are very pronounced in carnivores. Okay, carnivores are things like wolves and lions and tigers and that kind of thing. Then we have premolars, and those are between the molars and the canines. Okay, so those are typically the 2 to 3 teeth in between the molars and the canines. And then we have molars, or real molars, if you will, and those are for chewing and grinding. All right, so animals such as cows have mostly molars, right? And going to the next one, you'll see some examples. So omnivores. Omnivores are mammals that eat both meat and plants. So an example of an omnivore is a human. Know what an omnivore is, okay? Know that an omnivore eats plants and humans. That will help you in knowing the types of teeth that humans or omnivores have. And they possess pretty much all of them. They possess molars, they have incisors, they have canines, and they have premolars, okay? They possess all of the types of teeth, all the different dentition in a mammal jaw. And they can move side to side and up and down. Okay, so side to side would be for grinding things like plants. Up and down would be for mashing things or tearing things like meat. Carnivores have very few molars, if any, and their jaw only moves up and down. Okay, this would be an example of a very elongated canine indicative of a carnivore. Okay, and I believe this looks mostly like a dog bone or a dog jaw based off the premolars and the molars. But you can see how there's very few molars here. There's only like 2, maybe a small third one. But most of these are going to be like premolars, a little bit of incisors, but really pronounced canines. These pronounced canines, whether they're lower jaw or upper jaw, really are indicative of the carnivores. And finally, we have herbivores. Herbivores are those animals that only eat plants, and they have mostly molars. So example would be a cow. In a cow, your jaw moves laterally, so side to side, and it's done to grind up the vegetation that it's eating. It primarily will have all molars, okay, molars and premolars. Very rare instances will it have an incisor, and in a cow, these guys are basically all molars. So cows are basically all molars. Know that. And now we're looking at a mammalian heart. All right, so we have four true chambers, if you will. We have the right atrium and the right ventricle, the left ventricle, and the left atrium. Okay, and again, you'll look at the left atrium and left ventricle are really on what we would consider, looking at this, the right side. All right, so the heart is facing us just like you, a partner of yours, would be facing you. So left is really, what would be our right, and right is really our left. Anyway, know the blood flow, know 4 chambers, and what you see here is this blue area. This is deoxygenated blood, so blood coming from the heads and the arms are going this way. From the trunk and the legs are coming up, and they go into the right atrium. This gets circulated into the right ventricle. The right ventricle shoves the blood into the pulmonary artery and either goes to the left lung or right lung to be oxygenated. The returning blood from the lung comes in through these guys, okay, and goes through and funnels into the left atrium. It goes into the left ventricle and gets shoved up through the aorta, which is here. This is that aortic arch, and you can see how the blood flows to the left, okay? And again, this is the left side of a mammal's heart, so it flows to the left, okay? So that is one of the characteristics of a mammal. Remember that from one of those previous slides. And that is a mammalian heart. Our Geek of the Week is Dr. Vivien Thomas. He was born on August 29th, 1910. He died in 1985. He worked with Dr. Alfred Blalock. He was the first man to perform open heart surgery without an MD. So kind of crazy there, without the MD. His claim to fame was he was the co-creator of a procedure to surgically correct blue baby syndrome. And that is a cyanotic disease where you have the body has problems getting enough oxygen to the extremities of our body. So most times these types of syndromes happen are visible mostly in our fingers and our toes or our hands and our feet, okay? Where the capillaries just sometimes, if you have this blue baby syndrome as an infant, have a hard time. So they were able to surgically create that. And what they did was working with Dr. Blalock and Dr. Taussig, and we should just have a third name in here, Dr. Thomas. Now it's most commonly known as the Blalock-Taussig, but we should actually put Thomas in there as well. And what they came up with was this Tetralogy of Fallot, or this shunt. So they added this aortic branch, okay, and they diverted it into the pulmonary artery. Now remember, from a couple slides ago, the pulmonary artery, this guy, has blood flow going to the lungs. So when they put this shunt in, they diverted some of the oxygenated blood back to the lungs, all right? And what this did was it increased the blood flow, which allowed for blue baby syndrome to not really be of an effect, which is pretty cool, okay? So for your test, know Dr. Vivien Thomas, know he did the first open heart surgery without an MD, and that he was one of the co-creators to surgically correct blue baby syndrome, okay? And I believe that is it for our lesson today. Your video secret number is going to be 211, okay? Video secret number is 211. Thanks so much for watching, and I will see you guys in class. Bye now.